This tutorial is about cutting of circular microwells in the Baxter algorithms. Here I have two image sequences with 50 frames each. They have muscle stem cells in circular microwells with a diameter of 600 microns. I have performed image stabilization on these image sequences, and now I'm going to cut out a square containing the microwells. This can be useful if you want to speed up the processing, because you don't have to process as many pixels if you do this, and you also get nicer figures for papers and stuff like that. And if you want to perform image stabilization and cutting on a dataset, you should do the stabilization first, because the stabilization can introduce image artifacts at the image boundaries, and then if you cut afterwards you get rid of these artifacts. So to perform the cutting, we go to automated cut microwells, and then the program tells us that we need to specify the minimum and the maximum well radius, and that's done in the settings. It is an advanced setting of the image category. So here we need to know the minimum and the maximum radius of the microwells in pixels. And to find that out, we look at the original images. We see that they have a height of 1040 pixels. So the height is definitely not above 500 pixels, and it's not less than 400, I don't think. But to be sure, we can set the lower limit to 350 pixels and the upper limit to 550 pixels. Then we save these settings and try again. So we go to the cutting dialog, and then we're asked where we want to put the cut experiment. And the default location is a folder named the same thing as the original experiment, but with _cut appended to the folder name. And we will go with that, and then we select to use two processor cores, because then the image sequences will be cut in parallel. One processor core will process each image sequence. And then we can look in the terminal window to see the processing. First, the program starts the parallel processing workers, and then the program will try to find the circular microwells in the image sequences, and that will take quite some time. Then once that is finished, the cutting of the image sequences will be extremely fast, but finding the microwells will take a couple of minutes. Once the processing is finished, we're asked if we want to open the cut experiment, and we press yes, and then we see that we now have two cut image sequences where only a small boundary around each microwell is kept. And that's of course true for the entire image sequence.